NEC 250.34 addresses the grounding requirements for portable and vehicle-mounted generators. Understanding this section is crucial for ensuring electrical safety when using these generators. NEC 250.34 outlines the specific conditions under which portable and vehicle-mounted generators must be grounded. These conditions are: firstly, if the generator has a non-current carrying metal frame; secondly, if the generator is used in wet or damp locations; thirdly, if the generator is connected to a grounding conductor; and fourthly, if the generator is located within 25 feet of a building or structure. Let's break down each of these conditions to provide a clearer understanding. The first condition states that a portable or vehicle-mounted generator must be grounded if it has a non-current carrying metal frame. This means that if the generator's frame is made of metal and does not carry electrical current under normal operating conditions, it needs to be grounded. Grounding the metal frame provides a path for fault current to flow back to the source in the event of a short circuit, thereby reducing the risk of electrical shock. The second condition requires grounding if the generator is used in wet or damp locations. Water is an excellent conductor of electricity, and using a generator in wet or damp environments significantly increases the risk of electrical shock. Grounding the generator in these conditions provides a low impedance path for fault current, helping to quickly trip a circuit breaker or ground fault circuit interrupter (GFCI) and energize the circuit. The third condition necessitates grounding if the generator is connected to a grounding conductor. If the generator is part of a system that includes a grounding conductor, such as when it is connected to a building's electrical system, it must be grounded. This ensures that the generator is properly integrated into the overall grounding system, providing a consistent and reliable path for fault current. The fourth condition mandates grounding if the generator is located within 25 feet of a building or structure. This requirement is based on the proximity of the generator to potential grounding points such as metal water pipes or building steel. If the generator is close enough to these grounding points, it is more likely that a fault current could find a path to ground through the building or structure, creating a shock hazard. Grounding the generator in this situation helps to control the path of fault current and minimize the risk of electrical shock. It is important to note that these conditions are cumulative, meaning that if any one of them is met, the generator must be grounded. For example, even if a generator has a non-metallic frame, it must still be grounded if it is used in a wet location or is located within 25 feet of a building. Now, let's address the specific scenario involving portable generators used to operate submersible pumps. In this situation, flexible conductors are attached to the lugs in the generator and run to enclosed disconnect switches. Flexible conductors then run from the disconnect switches to the submersible pump. Based on this setup, the portable generators may not be required to be grounded according to NEC 250.34 if they meet certain criteria. Firstly, if the generators are not used in a wet or damp location; secondly, if they are not connected to a grounding conductor; and thirdly, if they are not located within 25 feet of a building or structure. Let's examine each of these criteria in more detail. The first criterion is that the generators are not used in a wet or damp location. Since the generators are connected to enclosed disconnect switches, they are not directly exposed to moisture. Therefore, if the disconnect switches provide adequate protection against water ingress, the generators may not be considered to be used in a wet or damp location. The second criterion is that the generators are not connected to a grounding conductor. In this setup, flexible conductors are used to connect the generators to the disconnect switches and pumps. These flexible conductors do not include a grounding conductor, so the generators are not directly connected to a grounding system. The third criterion is that the generators are not located within 25 feet of a building or structure. If the generators are used outdoors to operate submersible pumps and are not located close to any buildings or structures, this criterion is also met. Therefore, based on these conditions, the portable generators may not be required to be grounded according to NEC 250.34a. However, it is important to verify that all three criteria are met in order to ensure compliance with the NEC. Now let's address the question of why manufacturers provide a grounding lug on portable generators even if grounding is not always required. There are several reasons why manufacturers include this feature. Firstly, future use. Secondly, customer misinterpretation. And thirdly, liability mitigation. Let's explore each of these reasons in more detail. The first reason is future use. A generator may be installed in a location where grounding is required, such as inside a building or within 25 feet of a structure. Providing a grounding lug allows the generator to be easily grounded if it is moved to a location where grounding is necessary. The second reason is customer misinterpretation. Manufacturers may provide a grounding lug to avoid confusion or incorrect assumptions that the generator requires grounding when it does not. Some users may assume that all generators must be grounded, regardless of the specific circumstances. By providing a grounding lug, manufacturers can address this misconception and provide a convenient means of grounding the generator if the user believes it is necessary. The third reason is liability mitigation. By providing a grounding lug, manufacturers may reduce their potential liability if someone incorrectly assumes grounding is required and then fails to do so, resulting in an accident. In this case, the presence of a grounding lug can be seen as a safety feature that encourages users to ground the generator when appropriate. While these are all possible reasons, you should consult the documentation provided with the unit to determine the manufacturer's intent. Here are some recommendations for ensuring safe and compliant use of portable generators. Firstly, check the manufacturer's instructions for the specific generator model to determine if grounding is required or recommended. Secondly, if grounding is not required, do not connect a grounding conductor to the generator. Thirdly, if grounding is required, ensure that a proper grounding electrode and grounding conductor are installed according to NEC 250.34. Fourthly, educate employees and inspectors in the correct NEC requirements for grounding portable generators in the specific situations you encounter. Let's delve deeper into each of these recommendations. The first recommendation is to check the manufacturer's instructions. The manufacturer's instructions are the primary source of information for the specific generator model. These instructions will provide detailed information on the generator's grounding requirements, as well as other important safety and operating guidelines. Always refer to the manufacturer's instructions before using a portable generator. The second recommendation is to not connect a grounding conductor if grounding is not required. Connecting a grounding conductor to a generator that does not require grounding can create a ground loop, which can introduce noise and interference into the electrical system. Additionally, it can create a potential path for fault current to flow through unintended conductors, increasing the risk of electrical shock. If the manufacturer's instructions on NEC 250.34 indicate that grounding is not required, do not connect a grounding conductor to the generator. The third recommendation is to ensure proper grounding if grounding is required. If the manufacturer's instructions or NEC 250.34 indicate that grounding is required, it is essential to install a proper grounding electrode and grounding conductor. The grounding electrode should be a ground rod, ground plate, or other approved grounding electrode that is installed in accordance with NEC 250.52. The grounding conductor should be sized according to NEC 250.122 and should connect the generator's grounding lug to the grounding electrode. Ensure that the grounding electrode and grounding conductor are properly installed and maintained to provide a reliable path for fault current. The fourth recommendation is to educate employees and inspectors. It is important to educate employees and inspectors on the correct NEC requirements for grounding portable generators in the specific situations they encounter. This education should include a review of NEC 250.34a, as well as the manufacturer's instructions for the specific generator models being used. Additionally, it should cover the potential hazards associated with improper grounding and the importance of following proper grounding procedures. By educating employees and inspectors, you can help to ensure that portable generators are used safely and in compliance with the NEC. In summary, Understanding NEC 250.34 is crucial for ensuring the safe and compliant use of portable and vehicle-mounted generators. By carefully considering the conditions under which grounding is required and following the manufacturer's instructions, you can minimize the risk of electrical shock and protect yourself and others from harm. Remember to always prioritize safety when working with electrical equipment and to consult with a qualified electrician if you have any questions or concerns. Now let's delve into some additional considerations related to grounding portable generators. One important aspect to consider is the type of grounding system used. There are two main types of grounding systems commonly used in electrical installations. Firstly, the grounded system, and secondly, the ungrounded system. In a grounded system, one of the conductors, typically the neutral conductor, is intentionally connected to ground. This provides a reference point for voltage and helps to stabilize the electrical system. In an ungrounded system, none of the conductors are intentionally connected to ground. This type of system is typically used in applications where a high degree of reliability is required, such as in hospitals or industrial facilities. When using a portable generator, it is important to ensure that the generator's grounding system is compatible with the grounding system of the electrical system to which it is connected. If the generator is connected to a grounded system, the generator's neutral conductor should be connected to the grounding electrode. If the generator is connected to an ungrounded system, the generator should be operated as an ungrounded system, and no connection should be made to ground. Another important consideration is the use of ground fault circuit interrupters, GFCIs. GFCIs are devices that are designed to detect ground faults and quickly de-energize the circuit, thereby reducing the risk of electrical shock. GFCIs are required in many locations, such as in bathrooms, kitchens, and outdoor areas. When using a portable generator, it is recommended to use a GFCI-protected extension cord or to connect the generator to a GFCI-protected circuit. This will provide an additional layer of protection against electrical shock in the event of a ground fault. In addition to grounding and GFCI protection, it is also important to follow other safety precautions when using portable generators. These precautions include, firstly, operating the generator in a well-ventilated area, secondly, keeping the generator dry, and thirdly, not overloading the generator. Let's examine each of these precautions in more detail. The first precaution is to operate the generator in a well-ventilated area. Portable generators produce exhaust fumes that contain carbon monoxide, a deadly gas. Operating the generator in a well-ventilated area helps to prevent the buildup of carbon monoxide and reduces the risk of carbon monoxide poisoning. Never operate a portable generator indoors or in an enclosed space. The second precaution is to keep the generator dry. Water and electricity do not mix. Operating a generator in wet or damp conditions can create a serious electrical shock hazard. Keep the generator dry and protected from rain and snow. The third precaution is to not overload the generator. Overloading a generator can damage the generator and create a fire hazard. Check the generator's rating plate to determine its maximum power output and do not exceed this limit. Use a power meter to monitor the generator's power output and avoid overloading it. By following these safety precautions, you can minimize the risk of accidents and injuries when using portable generators. Remember to always prioritize safety when working with electrical equipment and to consult with a qualified electrician if you have any questions or concerns. Furthermore, let's discuss some specific scenarios and applications where portable generator grounding is particularly important. One such scenario is when using a portable generator to power sensitive electronic equipment. Sensitive electronic equipment, such as computers, audio equipment, and medical devices, can be susceptible to damage from voltage fluctuations and electrical noise. Grounding the generator in these situations can help to stabilize the voltage and reduce electrical noise, thereby protecting the equipment from damage. Another scenario where grounding is important is when using a portable generator to power equipment that is connected to a metal water pipe or other grounded metal structure. In these cases, grounding the generator can help to prevent the metal structure from becoming energized in the event of a ground fault. This can reduce the risk of electrical shock to anyone who comes into contact with the metal structure. Additionally, grounding is crucial when using a generator on a construction site. Construction sites often have temporary electrical systems and exposed wiring, which can increase the risk of electrical shock. Grounding the generator and ensuring that all electrical equipment is properly grounded can help to create a safer working environment. Moreover, portable generators used for emergency power during outages require careful grounding consideration. When connecting a generator to a building's electrical system during a power outage, it is important to ensure that the generator is properly isolated from the utility grid. This can be accomplished by using a transfer switch, which prevents the generator from backfeeding power into the utility grid. Grounding the generator and the transfer switch is essential for ensuring that the electrical system is properly grounded and protected from ground faults. Understanding the differences between separately derived systems and non-separately derived systems is also critical when dealing with portable generators. A separately derived system is an electrical system that is powered by a source that is not directly connected to the utility grid, such as a generator or a transformer. In a separately derived system, the neutral conductor must be bonded to ground at the source. A non-separately derived system is an electrical system that is powered by a source that is directly connected to the utility grid. In a non-separately derived system, the neutral conductor is already bonded to ground at the service entrance. When connecting a portable generator to a building's electrical system, it is important to determine whether the generator is operating as a separately derived system or a non-separately derived system. If the generator is operating as a separately derived system, the neutral conductor must be bonded to ground at the generator. If the generator is operating as a non-separately derived system, the neutral conductor should not be bonded to ground at the generator. Finally, it is important to stay up to date on the latest revisions to the NEC and other applicable electrical codes. Electrical codes are constantly evolving to reflect new technologies and safety practices. By staying informed about the latest code changes, you can ensure that you are using portable generators safely and in compliance with the current regulations. In conclusion, grounding portable generators is a complex topic that requires careful consideration of various factors, including the type of equipment being powered, the location of the generator, and the type of electrical system to which it is connected. By following the recommendations outlined in this discussion and consulting with a qualified electrician, you can ensure that you are using portable generators safely and in compliance with all applicable codes and regulations. Remember, safety should always be the top priority when working with electrical equipment, and it is highly recommended to consult with a qualified electrician in your area to clarify the local codes.